Hi, my name's Tim Cruz. I'm an IoT specialist, solution architect for Amazon Web Services. And I'll be talking to you about how customers are solving business problems today on AWS and how IoT is a core functionality of helping them successfully drive business outcomes. As part of that, what we'll also talk about is the complexities of the edge in an IoT landscape. And then we'll talk about how you can start making smarter decisions at the edge on the data that you're receiving. And since this is a 300 level track, we'll do a bit of demos, assuming these demos work. And I just lost my Alexa. So we'll come back to that a little later. So when we talk to our customers, and we engage with our customers around their business outcomes, especially around IoT, we like to start our conversations with a simple question. If you knew the state of everything and could reason on top of that data, what problems would you solve? Well, at AWS, we've made it our mission to make sure that you can know the state of everything. You can know the state of all your devices. And with that, you can start reasoning on your data. And we provide a lot of services that allows you to parse and analyze that data. And doing so, that allows you to make some truly significant solve some business problems. And we have customers that are solving these business problems every day. Whether it's iRobot that are connecting their robot vacuum cleaners, and they're connecting them, monitoring, controlling them. And this is to improve the functionality of their robots, as well as sort of improve the outcome for their customers. We have Enel, a European energy company. And they are using AWS for their IoT energy platform. They're using AWS Greengrass for their home smart gateways, as well as industrial gateways for smart generation of energy sites. And using AWS Greengrass, they can process large amounts of data at the sites in sub-millisecond latency. Rio Tinto is also a great use case of a mining company that operates in extreme environmental conditions where data connectivity is actually really difficult. And they're using AWS IoT and AWS Greengrass to solve some operational problems and headaches around the maintenance of their trucks. By using AWS Greengrass, they've managed to sort of map out and monitor and track the truck movement around their boron mine sites to basically heat map the roads to reduce the wear and tear of their trucks. And this is saving them millions of dollars a year. Symantec's another example with their core home router, which is using AWS IoT to secure your home routing from inside and outside traffic. And these are just examples, but all of our customers are building their IoT stories and solving their business problems across industries, across verticals, for any type of use case. We talked about predictive maintenance with Rio Tinto, where they're ahead of the curve trying to maintain their trucks before they fail. But Sony's another example where in their manufacturing facilities, they've IoT'd their machineries and try to monitor, track their machines before they break down so that they can improve their efficiency. In the wellness and healthcare space, we've got Philips Healthcare that have built their IoT AWS digital platform called Health Suite, where they're supporting and helping their customers, their patients globally. In connected buildings, who here doesn't have a light bulb today? One of those light bulbs that you can interact with and use her when she responds when I talk to her. Alexa, she's still there, stop. In the fleet management and tracking solutions, today you can know the state of your fleet. You can know the state of your cars out on the field. By tracking them, you can improve your supply chain, you can improve your logistics, your operations, all of this enabled by IoT. And so when we talk to our customers, we see really two axes that help our customers drive significant business outcomes. One of which is operational efficiency. IoT data decreases your OpEx. By knowing the state of all of your devices, of your machinery, your operations, you can increase the efficiency of your operations. But also knowing the data, you can make data-driven decisions and make the right decisions intelligently for your business. And then we have the customers that are using sort of IoT to drive new business growth. We've got customers that are building new services, new products, and creating completely new business models leveraging IoT. We've got customers that are actually increasing the functionality of their products using IoT. And a great example of that is Sonos, the smart speakers. They've retrofitted their existing fleet of speakers with AWS IoT, increasing the functionality and reaching out to their customers in a better way. And IoT allows you to build better relationships with your customers. And the best person I know to talk about reaching out to their customers and really sort of improve the lifestyle of their customers and improve the relationship is Rishi Israni. Rishi is a serial entrepreneur, co-founder and CEO of Zimplistic, whose mission is to make healthy eating available to all using smart devices. Their first product is the Rotimatic. It's a smart IoT and AI-enabled flatbread making kitchen robot. Rishi and Petroni created Zimplistic in 2008. Please welcome Rishi on stage to join me to talk to you about his journey.
Thanks,
Thank you, Rishi.
Thank you. Hi, guys. I want to start my talk with a disclaimer. I'm not going to show you guys any code. This talk is a little bit about food tech, so it might get you hungry by the end of it, so it's at your own risk. This is also a story of a company that was dreamt of, born and bred, and brought to life entirely in Singapore. So that's something also to be very proud for us. Like a lot of you, I'm a software guy. And the first concepts I learned in computer science was GIGO. Anybody heard of GIGO before? It's garbage in, garbage out. Oh, somebody has. It's garbage in, garbage out. You put garbage instructions into a machine and the output is garbage. I mean, it's obvious. Well, we human beings are not very different. You put the wrong food in and the output is poor health. In my mind, the problem of healthy eating is actually very simple. All one needs to do to eat and live healthy is to go back to the basics, go back to the fundamentals, and just put the right food in our bodies. At Zimplistic, it is our mission to build machines where you are in complete control of the ingredients that go in, together with the convenience that we need for our modern lifestyles. Roti is a flatbread, and it's a very important and integral part of the Indian diet. It's super healthy, but it's extremely, extremely difficult to make. I shouldn't say this, but only the women know how to do it well. So when I got married, it used to take us 30 days on a daily basis to make this bread at home. And luckily for us, we were not the only ones. There are another 2.5 billion people who eat some form of flatbread or the other. You guys might be familiar with rotis, tortillas, wraps, pizza bases, and almost every culture has a flatbread of their own. Building a machine to automate this actually started as a joke. I used to poke at my mechanical engineer wife, and of course, she took it very seriously. It took us 8 years of R&D. 8 years of R&D and 35 patents later, we built a machine where you could pick the ingredients that went in, and at the click of a button, it made one ready-to-eat hot flatbread every 90 seconds. So that's where you see Rotimatic. The containers are for flour and water, and out comes a hot flatbread every 90 seconds. Now, making flatbread is no joke. It takes human beings multiple years of practice and skill to get it right. Automating it in a machine was even harder. Rotimatic has 10 motors, 15 sensors, and a lot of machine learning algorithms to simulate the human judgment of making dough. Anybody who's made dough here before would know that it's never the same every time. And all of this technology had to come together to give you consistent, great rotis every time. Now, if we take a 30,000 feet view of what Rotimatic is, most of us don't realize this, but there was a time when the world didn't have a washing machine. There was a time when the world did not have a microwave. And there was the first time for all of these. And from our point of view, this is the first time ever that the world is seeing a flatbread maker. And when that happens, the complexity of product development, the complexity of bringing a complex innovation like this to market, is just very new for everybody. It's just very hard to get it end-to-end right. And I want to talk to you guys about how IoT has formed the bedrock and the critical role it has played in our success. And I want to share with you 3 reasons why. Like I said, flatbread is eaten by a very large population in the world. And from day one, we knew that we were building a platform to support all the flatbreads. But it would not have been possible to launch all the flatbreads right from day one. Once we built connectivity into the product, that problem was solved for us. Now, we could launch a product with one recipe off the bat and slowly could evolve it to support all types of flatbreads in the world. So last year, we launched with roti. I don't know how many of you have eaten roti or chapati here. And now we've added puri and pizza base. And coming up is tortilla, gluten-free wraps, and many, many, many more. So it's added a big business value to our business where we could launch much faster. And it's also delighted a lot of our customers where they are happy to see new recipes magically appear on their machines. In the very first year of launch, our users have made more than 14 million rotis on Rotimatic. And we have more than 2 million feedback data points that has allowed us to understand our customers better, understand their behavior better. It has allowed us to quickly iterate and improve our product at a speed that was unheard of in hardware. So it's a big win for Simplistic to be able to do that as quickly. There's another big problem every hardware startup needs to look at, is to how do you service your products once you sell them. In our very first year of sales, we did 20 million in revenue, with our customers spanning in more than 100 cities. Now, the traditional after-sales model would have been to go open a service center one by one in every city. That would have meant a lot of time and a lot of money, of course. Instead, on the back of the IoT data that we have, all the sensor data that we have, we know exactly what's wrong with the machine. And hence, we could centralize our troubleshooting and use logistics to replace faulty units. This has been a big cost saving for Simplistic, and also it has ended up in a very delightful experience for our customers. So what's next? On the backbone of the usage data that we create, we are launching a consumables business. So now we know exactly when and how much flour you consume, and we know exactly when it will be running out. And we could deliver the most personalized and the freshest flour right to your doorstep. And for us, when we look at what we've achieved, we think this is just the beginning. I am personally super excited to see how the new connected robotic toolkit will transform the kitchen of the future. Thank you.
Thank you, Rishi.
Thank you.
I can't wait to get myself one of these Rotimatics, especially if I can put my feet under the table that does everything for me. So I'm just going to change my vibe a little bit. I'm going to try that demo again. Alexa. Okay, we just lost Wi-Fi.
Sorry, I'm having trouble understanding
Never
right
mind.
now. Please
So-
try a little later.
So as you saw with Rishi's presentation, is nobody buys IoT, right? They seek business outcomes. And IoT has been a strong enabler for companies like Simplistic to really build their business model and interact with their customers in a better way to create a much better product and a service. And so with AWS, our concept of IoT is really threefold. First starts with the devices, where as we're seeing more and more customers build out their IoT solutions, they're not connecting hundreds of devices anymore or thousands of devices. They're starting to connect millions of devices. So we need a very strong and robust and reliable connection of those devices to the cloud and make it very, very secure. Because security is AWS's job zero. Then, once the data hits the cloud, we need to store it. So we offer a plethora of storage services, S3 being one of them, as well as databases. But also we want to compute on that data, for which you have a lot of flexibility to analyze and process the data within the cloud. But then once you have all that data, you want to start making intelligent decisions, analyze this data at scale in larger volumes, and start making insights on that data. And you want to connect back to those devices to act in real time. And so for that, 3 years ago, we introduced the pillar of our IoT services, which is our now AWS IoT Core. And the AWS IoT Core service is centered around 4 building blocks. The first one is we recognize we need to get it deep understanding and connected to the devices themselves. And so this is why we started providing SDKs to allow our developers and allow our customers to put those SDKs onto their hardware to connect reliably and securely to the cloud. And so the security of those requires sort of TLS encryption, as well as mutual authentication using individual certificates per device. Once those devices are connected to the cloud and to our IoT device gateway, we use industry-grade open source protocols like MQTT, which allows you to communicate data to and from your devices to the cloud. Once the data hits the cloud, we then have our rules engine, which is really a routing engine, which allows you to route the data to the rest of the AWS services. You can then route that data for storage purposes into S3 or databases. And then you can execute and analyze and process that data by passing that data across to Lambda functions or any other API-based service that you choose. And the fourth capability is the capability to manage your devices once they're offline by managing the state of their device and having your applications, creating the ability for your applications to interact with those devices. But listening to our customers, we've evolved our AWS suite of services by increasing the number of services around that. And this was to manage the scale of what our customers were experiencing. With millions of devices connecting, customers needing ways to manage their fleet of devices more efficiently. They needed ways to manage the security and actually monitor and track the security posture of their fleet of devices. And then they needed ways to basically interact and analyze the data almost in real time as it's hitting the device gateways. And so for that, from a cloud perspective, we introduced 3 new services, which are device management, IoT device management, which allows customers to manage their fleet of devices, group them, interact with them, create jobs for those devices. We've created IoT Device Defender, which is using machine learning-backed models in the background to monitor and track your fleet of devices to try and see if we're seeing patterns that could have security implications relative to your security posture. And then we created IoT Analytics, which allows you to create sort of time-based series graphs of your data to analyze it further and go deeper into your data. And with those analyses, you can react back to your devices using the device gateway. But we also recognized that we not only needed to increase our posture in the cloud by providing more services, we also needed to address certain functionalities at the edge. By basically providing AWS Greengrass, we've solved the problem that our customers were facing where they needed IoT in situations like Rio Tinto in extreme environments where connectivity is slightly complicated. We also introduced Amazon FreeRTOS, which allows customers to actually implement AWS cloud connectivity into much smaller footprint device, much less powerful, microcontroller-based electronics. And that's why now we can talk about AWS Greengrass, because effectively when we talk about IoT, I mean, the simplistic use case is a great use case with those machines connecting to the cloud, but in some cases, customers have machines where the data actually doesn't reach the cloud. You have medical equipment where you don't have the time to have a loop between your data leaving the machine to analyze, sense on whatever it's sensing on your body or whatever, tracked, monitored, analyzed in the cloud, and then pushed back down on the machine to make a decision. You need that decision to be made in real time on the machine itself. Industrial machinery, where safety is a huge concern, you need to make those decisions in real time based on the ecosystem and what you're monitoring at the site. And then you've got extreme environments, where effectively, how do you get data connectivity to those places? And this is why we've recognized that there's actually 3 laws around the edge computing. And those are the law of physics, economics, and law of the land. Effectively, law of physics is recognizing that in some places you just can't have data connectivity. And even if you could, it would be highly complicated because maybe you need to transfer way more data than the pipes that you could lay or could support, or the latency would just be too high. The law of economics is realizing also that in some cases, it just becomes too expensive to transmit data. In the middle of Antarctica, for example, you need satellite connectivity. Each byte of data you're transferring is costing you a fortune. And then the law of the land. In some cases, your data just cannot leave the site in which it's at, or the country in which it's at. And you actually need to be able to make decisions on the data. You need to be able to analyze that data. And you need to do that locally. And that's why last year we introduced AWS Greengrass. And similar to AWS IoT, AWS Greengrass centers around 4 pillars. First one, security. We don't compromise on security. AWS Greengrass leverages the same security as AWS IoT, meaning TLS encryption for your data, as well as mutual authentication with individual certificates, the same certificates that you would use, your devices would use to connect to AWS IoT. We provide the shadowing concept, which allows you to monitor and track the state of your device locally to the Greengrass or the Greengrass gateway. And we have local triggers, which allows you to pass that data along to the different devices, as well as to the last feature, which is the Lambda functions. And this is the greatest feature of them all. Basically, for those that are have built Lambda functions in the cloud before, you can deploy the same Lambda functions you're used to building in the cloud onto your Greengrass device. That gives you much higher level of computing power, as well as protocol, languages that you can leverage by Node.js and Python to build your business logic. And in Greengrass, one of the differences is your Lambda functions can start running long-running functions rather than event-driven, depending on your use case. And then listening to our customers even further, recently we introduced more features for AWS Greengrass. One is the ability to over-the-air updates. Customers were wanting to be able to update the software remotely on a fleet of their devices. All of this managed through AWS Device Management. For all of the customers that are in the industrial space, we created adapters for OPC UA, which allows you to use Greengrass in an industrial context, leveraging a standard protocol for industrial use cases and industrial machinery. And another great feature is local resource access. This means your Lambda functions executing on Greengrass can actually access the hardware on which it's running at. Your Lambda functions can trigger GPIOs on the device, or you can access specific hardware of the CPU, for example, GPUs. And this is where it comes really handy because one of the features is local machine learning inference. Now, this slide isn't up to date because effectively, we launched machine learning inference general GA 2 or 3 days ago. And what this means is you can take the models that you've been building and training in the cloud using services like SageMaker or your own tool sets, and you can deploy those machine learning models down onto your devices. What that means is as soon as your device is tracking, monitoring, sensing data, you can run the machine learning models on that data, infer results, and act upon them in real time. The bigger the model, the more complex. You may need GPU resources, and in some cases, you just need to do some time-based analytics. You have complete freedom as to how you want to interact with your data. And the value of machine learning inference at the edge is great, and it actually solves those 4 sort of complex problems that we talked about before. From a latency perspective, since you're running your code and your machine learning models and inferring on that data locally to Greengrass as soon as you're monitoring and sensing the data, you don't have latency issues anymore. You don't have to wait for the data to hit the cloud, do some analysis, process, and then come back down. You can have access to that data in somewhat real time. You don't have bandwidth requirements anymore, because effectively what that means is if you're sensing a lot of data, a lot from different sensors, you can then sort of track and filter out the noise directly on the device so that you're only sending the relevant data to the cloud, minimizing the amount of data you need to send. From an availability perspective, all the data is locally to your Greengrass device, and you can act upon it instantly. And from a privacy perspective, well, the data doesn't have to leave the cloud. In some cases, you could run your whole business logic on a Greengrass device without even communicating any of that data to the cloud, specifically if machine learning models are sort of inferring on that data. So what I thought I'd do, since this is a 300-level track, is jump into a bit of a demo. Unfortunately, my good friend, which I'll mute right now, my good friend Alexa is not connecting because of the Wi-Fi. And what you should have seen is my water dispenser here. I would have asked Alexa to pour me a drink, which she would have using my IoT device here. Have no fear, that's just the Wi-Fi. What we'll do is we'll jump into a demo and we'll try to make my water dispenser smarter. Hopefully my water dispenser is connecting. If not, we'll just focus on this part of the demo. And so I don't know if you guys can see what my good friend here with the camera is showing, but here I've got a Raspberry Pi with a camera. And so I don't know if you guys are familiar with the DeepLens device that we also announced at reInvent, which is really sort of a compute platform with a camera which allows you to run Greengrass and machine learning inference and image recognition on a device. I believe the Intel booth outside has a DeepLens camera, and they can talk to you about it. But I don't have a DeepLens camera, so I decided to build my own. And the idea behind it is to recognize objects onto my from my Raspberry Pi. Oop. So if we jump to my demo screen, I don't know if I'm just going to refresh the page. Hopefully we're still connected. Yeah, we are. You guys flipping to my screen? There we go. So this is what the AWS Management Console for IoT actually looks like. And so here I've got my Greengrass device, which I've created a group for, which is my Singapore 2008 group. I don't know if you guys can read it. Basically here. Oop. Here. And for that, I've created sort of two Lambda functions that I've already deployed onto the device. One of those Lambda functions is actually my model, which is using an MXNet-based model, train model, for recognizing objects coming from the camera. And so that Lambda function is just taking pictures constantly of what it's seeing and trying to infer objects from that scene. My second Lambda function is what I've called the sense hat, which if once you had the camera before, there was a bunch of LEDs on the device, which would allow me, depending on what I'm detecting, to act on certain other functionalities. And in this case, I'm acting on the LEDs themselves to trigger certain functionalities. So if we look at the IoT service, I've got an MQTT client for which I can connect in, and on a specific topic over MQTT, in this case, I've created a topic called Singapore 2018 Inference. I can see what the camera is actually seeing and inferring. In this case, you could see a different probability. Oh, maybe I should zoom. Here we go. I mean, the last reported prediction is it's detecting a mosquito net, right? And a shower curtain. But have no fear. I've actually come with props. I've got a little car. So what we're going to do is, if we flip back to, oh, you guys can see it here. Great. If I put a car in front of it, hopefully, depending on the lighting, sometimes we have a bit of issues, the light should turn green. Yay! It works. So basically, I've just connected and detected from the camera, I've detected a car. And if we look back to my screen, I'm having the guys flip. We should see in the list of things that are detected somewhere, where is it? Well, anyway. We should have a car being detected in there. The feed is happening too fast. But I've also decided to detect a coffee mug. So if I take it off, it stops, it's not green anymore. And if I do this, I think I chose in my code to make it blue. There we go. So I'm detecting different objects, and I'm acting on the actual hardware. That hardware is local to the Raspberry Pi, but it could be elsewhere. So the reason I wanted to try and make this smarter and also show you the power of AWS Greengrass is, let me put the mug here, is what we're going to do is, well, first of all, we're going to modify my Lambda function right now and redeploy it live onto my device. So this is, I just basically log into AWS Lambda the same way you would, and I've already pre-packaged my Lambda function, but I've just commented out part of the function, which allows me to, based on what it's seeing, report that back on a different topic. So I will just save my Lambda function. Please, internet connectivity, work. Come on. There we go. I'll publish a new version of that function. And since I'm referring to that Lambda function in my Greengrass device via an alias, I will just move the alias across to the last version, which is version 6. So here we go. Come on. Stop using the internet. You're slowing it down. Whoop, what have I done? Aliases, here we go. Singapore. I'll refer to the version 6. So I've saved my Lambda function, and now within my Greengrass group, I can just deploy this new version of my Greengrass group, which will then package up the new version of the Lambda function and deploy it onto my Greengrass device. And what we should start seeing once the deployment has finished is if we subscribe to a different topic, which is, in this case, I've created Singapore 2018 cents. And let's come back here to see how we're doing in terms of progress. Usually it takes a couple seconds. Come on. While it's doing that, what I'll do is, what I wanted to do with this demo is sort of update the Greengrass core, update its Lambda function to show you how you could do that and deploy one. But what I'll also do is, once it's reporting that information, I'll create a rule. Remember how I said that you could send your data across? There we go. We could see it's successfully completed. So if I come back to my sensing topic, if I put the car here, I should go green at one point, depending on lighting. Come on. Give it a couple secs. We should see it here. While it's trying to update itself, what I'll do is I'll log into the rules engine, and I've pre-created a rule, which is my coffee mug rule here, which I'll enable. And what that rule actually does is, since my water dispenser hopefully is connecting over Wi-Fi, what it will do is, what I've decided to do is, if I detect my coffee mug, right, I'm reporting the coffee mug onto a different topic, which will then trigger, hopefully, my water dispenser. You could imagine putting that camera inside the water dispenser itself. So that should go blue, and there we go. Oh my gosh, it worked. There we go. Cheers. Unfortunately, it's just water. So you saw how easy it is to deploy new versions of your Lambda functions instantly on a Greengrass device. The more powerful the Greengrass device, the more powerful you can make your machine learning inference models, especially once you start using GPU-backed hardware like the NVIDIA platforms. So I hope this enlightened you relative to our IoT suite of services. And now I'll leave you with this. It's sort of, now that you know how you can know the state of everything and that you can reason on top of that data, what problems would you solve? Thank you for your time, and see you next time.